Hey guys, let's discuss new topic from system design, which is called messaging queue. So in messaging queue, what is messaging queue? So messaging queue is a system that enables async communication between services. So let's say you have one service A, okay? Let's say you have one service 1 and second service 2. So initially maybe they are communicating each other with synchronized manner. Okay, now what is synchronized manner? Synchronized manner means let's say you have service 3 as well. Okay, then after that they will call to service 3. So service 1 is calling service 2, service 2 is calling service 3. Sequentially they are calling each other. Okay, so step by step one service 2 will get called, after that service 3 will get called. So they are tightly coupled with each other. Okay, can't we do something like this, that service 1, once service 1 done with his work, there should be some queue. Okay, and then he will notify this queue, or he will say like placed order placed. Okay, so then service 2 or service 3, which are waiting for service 1 response, they can consume this value from this queue, and will start its function will it start its functioning independently. So you can see that this is async communication. Why async? Because the service 2 or 3, they are not waiting for each other. Okay, to like service 3 is not waiting to service 2 to complete his task and then service 3 will start. They both are working independently at the same time. Okay, so for example, and this kind of method is called synchronized communication. Okay, they are in sync. So let's say a user has placed one order. Okay, you order something from Amazon or somewhere. Okay, so you placed one order. So this order service, okay, this is the order service, let's say. So order service will do its task and then will say that order is created. So order is created, so there is one queue, let's say. So in this queue, it will notify this queue that order is created. Okay, now there are 3 services, let's say service 2, service 3 and service 4, and those services are like notification service, okay, and analytics service, and then delivery service. So once the order is created, okay, notification will see that okay, order is created, so he will start his work. And then similarly analytics service will also do his work, and then S4 means delivery service will also start his work. So you can see that S2, S3 and S4 are independent with each other. Okay, notification service doesn't need any data from analytics service or delivery service, and same for other two. So here they are loosely coupled. Okay, they are loosely coupled, and in the previous scenario, when it is serialized, when it is synchronized, that time it is tightly coupled. Okay, means the output of S3 depends on output of input of S2. So now here these kind of mechanism we can achieve using messaging queue. Okay, so using this queue we will use here between the services, and we can achieve that. Now you have 2 types of queues. First one is Kafka, okay, and second one is RabbitMQ. So we will study in detail these 2 services, messaging queues. Okay, and then before that, let's discuss that without MQ what was the problem, and with MQ what is the solution. So without MQ, what was the problem? The first one was the services was tightly coupled, right? We just discussed it, they were tightly coupled. Then second, the response was slow. Okay, so slow response, because definitely S3 is waiting for S2 to complete, then the entire response you will the user will get when S3 completes its work. Okay, last service. So of course it will be slower. Okay, response will be slower. And then third one is failure propagation. So failure propagation means let's say if here the service 2 gets failed, so service 3 will also get failed. Even service 3 has not started his work, but still this failure will propagate to the next services, and in the response the user will get that the process is failed. So failure propagation. Now with MQ, what problem we solve? So first of all, we make this tightly coupled services to loosely coupled or decoupled. Okay, so first we have decoupled the services. Then second, scalability. Okay, now here you can add any number of services and they can parallelly start their work, right? Then the third one is fault tolerant. So here, if this service is failing, it will not impact other services. And the fourth one is better performance. So here the performance is better because you will get response very quickly. Yeah, so now let's discuss the core concept of messaging queue. So let me remove this first. So in core concept of messaging queue, you will have 5 concepts. The first one is consumer, producer, consumer, and then message, okay, and then queue, topic, and broker. So let's discuss one by one each concepts. Okay, so here you will have first, let's say, producer. So producer, first one is producer, second one is consumer, okay, and third one is your queue, or you can say topic as well. Okay, so in Kafka it will be topic, in RabbitMQ this one will called queue, and the fourth one is your broker, okay, or you can say message manager, and then the fifth one is message, which is your actual data. So now here producer is something you can say message sender. Okay, so first you will have a producer here, then you will have a broker here. Okay, so you are sending message to broker, and inside broker you will have a queue or a topic. Okay, queue or a topic, anything, and then after that you will have a consumer which will consume this message. So producer, you can say this is a message sender. Okay, create and send messages to the messaging system. So this is your messaging system, it will create and send message. So for example, you can say that you are sending a parcel to someone, so you are a producer because you are sending parcel to a courier or parcel to someone else. So now let's talk about, so this was about producer. Now let's talk about consumer. So consumer means system that read and processed these messages, okay, from queue or topic. So they will read message from queue or topic, whatever it is. Now in real life analogy, you can say that receiver gets parcel and open it, okay, the other person, so he is consumer. Now the third one is broker. So what is broker? Broker, or let's talk about queue and topic first. So queue and topic, okay. So in, as I told you, that in RabbitMQ you use queue, and in Kafka we use topic. So you can tell them as a message store, okay. So where you store your messages, like in warehouse, you send your you're sending, and then the company's storing your parcel for some time in that warehouse. So that is called the message store or a broker, okay. Now so this one is FIFO, first in first out, in this queue or RabbitMQ, okay. And in Apache Kafka, this one will be topic, and messages are stored in partition. So here messages will stored in a partition, and in queue so it is first in first out. So now from here multiple consumer can read these messages, okay, at the same time. Now the next one is, so this one was about queue and topic. Now next one is broker. So message manager, you can say, system that receives message from producer and store them, okay, and delivers them to the consumer, and you can call it as brain of the messaging system. So this is the one which do all the task. Which all the task? So like delivering the message, and then store the message, and then handle the failure of a message. All these things done by broker. And then last one is message, okay. And one more thing, so broker in Apache Kafka, we call these broker as Kafka broker cluster, okay, Kafka broker cluster. And in RabbitMQ we called it as RabbitMQ server, okay. So different name in different types of MQ. Now So in real life analogy, you can see blue dot. Okay, so through blue dot you're sending your parcel. So you are producer because you're sending your parcel. This broker is the blue dot company, okay, which is sending your parcel, storing them in their warehouse, and then this consumer is the person who wanted to whom we are sending the message, okay, this courier or a parcel, and then message is actually your courier, okay, or a parcel. So here here you will have a different things in messages. So the first one is you can say that first one, the format of these messages can be JSON or JSON or XML, okay, anything it could be. And then after that so this is the actual data being transferred, and the key here, three things are there. First one is key, okay, on the basis of what you are partitioning the data. And then the second thing is payload, your actual data, okay. And the third one is metadata. So which kind of metadata? It is like timestamp, okay, or headers, this kind of thing. So there are multiple parts of these messages. Usually we have this kind of things, right? So now if you see you have order service, okay, so you have order service. Then so this order service will publish one event, okay, and then the notification service or delivery service or analytic service will so multiple consumers you have which will react on that event. So this kind of system we do, this kind of mechanism we do using this messaging queue. Okay, so now let's talk about messaging queue in theory part. Okay, let's see the structured way. So I have created this document for you. I will upload this document on Drive as well, and then link its path in the comment section, and will pin that comment, okay, so that it will be on top and you can always download this document. So this is about the messaging queue, Kafka and RabbitMQ. Okay, so what is messaging queue? Whatever I just discussed, we will see here. So a messaging queue is a system that enables asynchronous communication between services. Okay, instead of direct API call, service A send message to queue and service B consume message later. Okay, simple example, if you see here, first you see the diagram. So first you will have a producer which is sending the message on a queue, and then consumer is using that message. Now simple example, if you see user place order on e-commerce site, okay, this is we discussed. Order service pushes message to queue, okay, and then payment service, inventory service, notification service consume independently. They don't need to wait for each other. Why messaging queues? So let's see synchronized and asynchronized communication here. So synchronized communication, we have already talked that it is tightly coupled, it is slow response, failure propagation, these problems were there. So in asynchronized communication, see, if the services are not dependent on each other, they can run independently, then why to make them wait, right? So with MQ, asynchronous communication we work, okay, and then it will solve our problem, like it will do decoupling of the service, scalability, fault tolerant, and then tolerance, and then better performances. Okay, so for example here, if you see this diagram here, you have a process A and process B. Okay, so now process A is doing its task, and then suddenly it will call the process B. Then this process A has to wait, okay, until the response of process B, okay, will send the response, means it is completed, and then it will send the response, and then process A will continue again. So this is your synchronous processing. Now in asynchronous, see, process A call the process B. Till that time process A was doing his own work, something else, then response will come, and then again it will continue with its work. So this is async processing. Now here the core concept, if we have already talked about this core concept, right? Producer, consumer, queue topic, or broker, and then messages. Okay, so you can go and read that. So this is exactly same. Now Kafka deep concept. Okay, now let's discuss about Kafka and then RabbitMQ. So in Kafka, you can see that you will have a producer, then you will have a consumer, okay, or you can have a consumer groups also, where which is the group of a consumer, okay, and then now you will have one broker, which is the message center, you can say, and inside broker you will have a topics, okay, and each topic is divided into partition, which is called the partitions. So this is the simple architecture of the Kafka. Okay, Now here there are some rules. So for example, if this is a group of a consumer, okay, let's say this is group A. So in this group A, you have 3 consumers. So if consumer 1 is reading from partition 1, okay, let's say this is your partition 1, 2, 3, 4, 5, 6. So if consumer 1 is reading from partition 1, then consumer 2 cannot read from partition 1, because both consumer belongs to the same group, okay, and from one group only one person can read about one partition, okay. But if you have independent consumers, then they can read from that partition 1, okay. So here in this three consumers are there in that group, so one will read from partition 1, second will read from partition 2, third one will read from partition 4. So this one will be the faster, right? So that's why we use consumer group. And also we use consumer group because let's say consumer fails, okay, so other consumer can read from the queue, okay. And we use the concept of offset here. So this one, let's say this is the offset, okay. Now we keep track like from where consumer 1 is reading. So currently consumer 1 is here, consumer 2 is reading here, okay. So we will keep that track. If both will get failed, or any one of them get failed, so next consumer will come, we will come to know that till where that particular consumer has read the message, and from where we need to start again. So that's why we use the offset here, and that is we use in Kafka and not in RabbitMQ. So that is the main difference. In Kafka you can replay, like you have sent messages to consumer, and or consumer read messages from partition, and then again they need to read it after 7 days. So they can again replay these messages, but in RabbitMQ that is not possible. So the first thing is partition, okay. So this is the most important concept, partition. Partition is unit of scalability, parallelism, and ordering, okay. So why scalability? Because see, we have divided, so first we were having broker. Inside broker we were having topic, okay, and then you publish your message on a topic, but you divided that topic into partition also, okay, one more level of partition. So multiple consumer can read your message now, okay, at the same time. So this is the scalability. And then parallelism, because both all the consumers are reading your message at the same time. And then ordering. So ordering means it will maintain the message order also, like you have divided one task into one message into multiple packets, okay, multiple messages. So those messages should not interchange their order. Consumer should read in a particular order only that message, otherwise it will not make any sense. So that we can do that using this partitioning only, right? So the order will maintain on partition level. So it means that in this partition the message is going will be in order, and this partition whatever message is going will be in order, okay, independently. Now so this is the partition. Without partition only one consumer can read, so that was the bottleneck, okay. With partition multiple consumers can read in parallel, so high throughput. Now example is partition 0 is read by let's say you have a you send order 1, 2, 3 on partition 0, and order 4 and 5 to partition 1, and order 5, 6 and 7 to partition 2, okay. So means you are sending the order in different partitions, and you can use this scalability concept, parallelism concept. Otherwise you have to wait for partition 0 to process all the order, and then you can send this 4 and 5, 6 and 7, right? So how messages are assigned? So you can assign messages by using keys, okay. So for example, if the key is user ID, so same key, same partition. User ID, let's say this partition is for user ID, particular user ID 1 to 100. This one is for 100 to 200. So that messages only will go to that partitions, okay, inside the topic. Ensure ordering on partition level, and then without key round robin distribution, okay. So in messages actually you have see the message you are sending, okay, the message you are sending to broker will have a few parts like key, value, okay, topic, and then partition. So this value is actually your data, and then this topic is you need to know that which topic you need to send the message. So these two are compulsory, but these two are optional. Key and partitions are optional. See, if you have given the key that user ID 1001, okay, you send it to this particular topic, this topic, so it will go and send that value to that topic, okay. But if you have not given this partition value or key value, then it will use the round robin algorithm, and let's say you have n number of topics, okay. So first it will send data to this, these and this, like this, okay. Now so topic will be same, but the partition inside the topic, okay, my bad. So you have broker, then you will have a topic, and inside the topic you will have a partition, and then in that partition it will send data on the round robin basis, okay. If these few values are missing, then critical insight: ordering guarantees within partition only. This is what we discussed, okay, not across partitions. Not across partitions means this partition and this partition we will not take a guarantee of ordering, okay, but message ordering, but whatever we are sending in this partition will be in order, that is for sure. So now partitioning always allows Kafka to scale horizontally while maintaining order at the partition level. Now consumer groups. So what is consumer group? First one was we talked about partition. Second we talked about consumer groups. So we saw this, right? We use generally for load balancing. Earlier only one consumer was reading, and now multiple consumers are reading from there, okay. So consumer group is set of consumer working together, and rule is one partition, only one consumer in a group. This is what I told you, that from one group only one consumer can read from one partition, but if the consumers are independent, then they can all read from partition, that particular partition, okay. So like you have a three partitions, okay, you have a three partitions, 1, 2 and 3, and you have a two consumers, C1 and C2. So here consumer A or consumer A, consumer B, you can say, okay. So consumer A is reading from partition 0 and partition 1, and consumer 2 will read from partition 2. Parallelly they are reading, right? Now what happens if consumers is less than partitions? So consumer, like here we have a two consumers and we have a three partitions, okay. Some consumers handle multiple partitions, this is for sure, like consumer A was reading from consumer 0 and partition 0 and partition 1, right? Now if consumer is equivalent to partition, number of consumers equivalent to partition, so this one will be the perfect balance and everybody will read from different partitions. Now if consumers are greater than partition, then extra consumers sit idle, that is we understood that, right? So why consumer groups, and why we have created that consumer groups? So load balancing, fault tolerance and horizontal scaling. If any consumer goes down, then other consumers are anyways reading, okay. So fault tolerance, and then horizontal scaling, you can add multiple consumers also if you wanted to speed up the reading thing, and load balancing also, only one partition consumer is not reading whole data, it is divided into different consumer. Now hidden power is publisher subscriber. So multiple consumer group is equivalent to multiple independent services. Example, analytics group, notification group, recommendation group, okay, each gets full data. So what is publisher subscriber? So here let's say this is your producer and this is your messaging queue and this is your consumer, and you have multiple consumers, okay. So once producer will publish data to messaging queue, so these consumers at the same time can read that data, okay. You don't need to wait that you have to send one by one to everybody, no. Like let's say this is your analytics service, your notification service, your recommendation service, so they will start work independently. So Kafka achieves both load balancing and publisher subscriber using consumer groups. So that's why consumer group is important here. That is the importance of consumer group. Now third one is offset management, okay. So I talked to you about this offset management, that we keep a track that till where the consumer is has read the data, or currently for which offset it is reading the data, so that if it will get fail, we can restart the data reading from new consumer from the point where he has left. So offset management tracking system core idea: offset is position of the message in partition, okay. Now let's say you have a, this is your partition, and this partition are divided into different chunks, which is called, let's say, offset. Okay, so then this offset, you have the 0 1 2 3 4, these are the offset 0, offset 1 2. So currently your order 1 is here, and your order, someone else has placed the order 2 is here, order 3 is here, and you have different consumers. So so this consumer is reading this order, this consumer is reading this order, this order. Okay, so you will keep a track. So now, why offset important tracks progress, enable replay, and ensure reliability. Okay, so in Kafka, actually we don't drop the messages. Okay, we keep that message in a system for particular time, so that after 7 days, let's say in 7 days some service is not working and the report is coming incorrectly. Now you need to check the last 7 days data and you need to replay it. Okay, so that thing we can achieve using Kafka and using this offset mechanism. How consumption works: so consumer read message, process it, and commit offset. Then it will commit offset. Okay, I have read till here, now I'm reading the other one. Offset commit type, so you have auto commit and then manual commit. Okay, so using commits only we will come to know that consumer has read the data or not. Okay, so auto commit is Kafka commits automatically. And then what is the risk here? Message loss. Okay, maybe consumer has not read it and Kafka has committed, yeah, this is done, right? So then you will not have then your message will get lost there. Then manual commit, so commit after processing, and this is slow, safer also, but of course slower, right? Now powerful feature, replay. What is replay here? So consumer can reset offset. Okay, bugs, example, bug fix, reprocess last 2 days data. Offset is managed by consumer, enabling replay and fault tolerance. Now the fourth one is retention policy. So what all three we have talked about. First one was partitioning. Okay, what we are checking here, this is the Kafka deep concept. Okay, so first we have seen the architecture of the Kafka, then what is partitioning in Kafka, then second one was what is consumer groups in Kafka. Okay, and the third one is offset management, and the fourth one now is retention policy. So what is retention policy? Data storage strategy. I told you that for last 7 days data we will not delete, we will store it. So core idea, Kafka store data for fixed time or size node based on consumption. Okay, it is not like that, okay, consumer has consumed it so delete it. No, it is not like that. So very important difference in traditional queue, message deleted after consumption. Okay, message, but in Kafka message stays after, even after consumption. So retention time, you have a time based retention, you have a size based retention. Okay, so what is time based? Keep data for 7 days and after 7 days delete it. Size based is keep maximum 100 GB. Okay, otherwise after that remove the old data when the limit reached. Now why retention is powerful? So replay capability. Okay, reprocess old data, multiple consumers, so different systems read at different times. Okay, you have a different consumers, and let's say consumer 1 has read that data. Now you have another system which is working in the night. Okay, so C2 C3 will read later in the time, so that's why we use this. And event sourcing, so full history of events. So for example, you can see like day 1 you stored it, day 2 you stored it, and day 7 you just delete it because retention equal to 7 days. So Kafka is not a queue, it is a log. Okay, it is a log where data is retained for a configured duration. Now advanced insight, if we talk about the Kafka, what it would be. So partition strategy is critical. Okay, this is the same thing like if you are partitioning data on the basis of key, then you need to intelligently select that key. Okay, so bad key is uneven load or hot partition. Only one partition will get all the load. Okay, everybody will read from there. So that kind of hot partitioning will happen. Now consumer lag, so lag, message is not yet processed. Okay, so high lag means slow consumers. And rebalancing, when consumer joins or leaves, Kafka redistribution partitions. So then redistributes partition. So like you were having 5 consumers and now one is leaving, so now you have a 4 partitions, consumers. So now Kafka will redistribute partition again. Okay, whether you join or leave, addition or subtraction of the consumer. exactly one semantics, so achieving using idempotent producer and transactions. See, exactly once means um, multiple times if Kafka, if producer is producing data, okay, but it should be processed only once. Okay, so that is idempotent, like multiple, if you process multiple times on that particular thing, still the result should be same. And transaction also. So in transaction, you know the ACID property, okay, either everything will commit or it will roll back. So that is the thing. Now partition enables scalability, okay, consumer groups enable load balancing, offsets enable tracking and replay, and retention enables Kafka to behave like a durable event log. So now let's talk about RabbitMQ. Okay, so in RabbitMQ, just one simple difference. So you will have a producer, you will have a consumers, okay, consumer group as well. And now instead of you will have a broker also. Now instead of directly sending data to the queue, you will have a exchanges, okay, multiple exchanges, and then these exchanges will send data to the queue, okay, on the basis of routing strategy. Either it will send directly the data to particular queue, or it will broadcast to all the queues. So this kind of things it will happen here in exchanges. So this is the concept, this is the diagram of RabbitMQ. Just one difference. Okay, now what is RabbitMQ? So correct deep answer will be RabbitMQ is routing based messaging system. Okay, why routing based? Because it is routing data that this data should go to this queue, this data should go to this queue. Okay, so it will use intelligence there. So routing based messaging system where messages are not sent directly to queue but at the first sent to exchange, which decides how to route them. Okay, so key idea, very important in RabbitMQ. Producer directly will not send message to queue, it will send to exchange and then to queue. Now what are the core concept of RabbitMQ? So the first one is exchange. Okay, very first, very important. So now brain of the RabbitMQ, you can say. So here exchange is routing engine, and types of exchange. So direct exchange, fan out exchange, okay, then topic exchange and header exchange. So 4 exchanges are there. Now what they do, direct exchange means exact match routing. You will have one routing key. Okay, so the message you are getting, it will have one routing key, and then these queues are also associated with routing keys. So which is exactly matching, it will just send to that queue. Okay, that is very simple one, direct exchange. So routing key, if it is order dot created, so queue bounds with the same key, messages goes to matching queues only. Okay, so all the queue which are binding with this order created will get the message. Now fan out exchange. So fan out means broadcast of all queue. Okay, this is very simple. So message is going to everybody. Ignore routing key and use case like notifications and pub sub model. Okay, so this is the use case for it. Now topic exchange. So what is topic exchange? Pattern based, right? Like here you have a pattern like star and hash. So okay, so like order dot star, payment dot hash. So example, wildcard supports wildcard. Example, order dot created, order dot updated. So it will send only that kind of topic, okay, which has this kind of value. So order dot created, order dot updated will come into this order dot star, whatever it is after order, will send message to all those queues. Now header exchange, routing based on message header. Okay, rarely used, we don't use it much. So second is queue. In a RabbitMQ, the second is queue. So queue is a message buffer. We have seen that, okay, where we store the data. FIFO by default, first in first out, can be durable, can be exclusive or auto deleted. Now example, so like email queue. So send email to user A, send email to user B, then we delete it. Okay, we don't keep it once the email is successfully delivered. Then third one is binding. So binding, rule connecting exchange, okay, to queue. So example, exchange is order dot exchanged, queue is the payment dot queue. So binding key, what will be the binding key here? Order dot created. If order created, then only you send this message to this exchange and that queue. So that is your bounding. So meaning if routing key is order dot created, send to payment queue. Okay, routing key. So what is routing key? Routing key is label on the message. So like this event equal to order created. Exchanges uses this key to decide which queue should receive message. So this is what we discussed. Okay, now what are the important concept? So important concept in RabbitMQ is first one is acknowledgement. Okay, so consumer must confirm I process message successfully. Consumer will send acknowledgement to RabbitMQ. So types, again here you will have a auto acknowledgement and manual acknowledgement. Okay, so if no acknowledgement means message is redelivered, again message will get delivered. And prefetch count, now what is prefetch count? It is related to consumer. Okay, in RabbitMQ, how many messages a consumer can take at once, means how many messages you can send him, that will be written in the prefetch count. If prefetch count is 5, so at once you can send him 5 messages only. So prefetch equal to one message at a time, prevent overloading. Durability, so message survive restart, durable queue and persistent messages. Now what is dead letter queue? Dead letter queue is very important. Let's say you send now let's say in a queue, okay, the message is there and consumer is reading that message. Now first time he has read it, so it got failed. Now you have given there retry equal to 3, so 3 times he will read that message, but still that message is buggy. So we will move that message to this dead letter queue. You will have one more queue, okay, and you will send all that data which is after retrying, okay, still it is getting failed. So in that DLQ, dead letter queue, so that manually person can check and see what is the problem there. Okay, so example, retry failed 3 times, move to DLQ. Very simple logic. When to use RabbitMQ? So now see, RabbitMQ you use when you need to do some background jobs like image processing, video processing. Okay, these kind of background jobs you can use RabbitMQ. Email queue, you need to send emails. Payment processing, okay, overnight payment processing, batch runs, so in that you can use RabbitMQ. Microservices communication or complex routing, when there is a complex routing, that time. Now when you where you need to avoid, when you have a big data streaming, event replay needed, high throughput. Okay, so in this case you will use Kafka, event streaming and all. Okay, so this is your diagram of the RabbitMQ, you can say, or the RabbitMQ broker diagram. So here in broker you will have an exchange, you can have multiple exchanges. Okay, now in this exchange you have different types like direct exchange, so binding key will be there. Okay, and then you have a multiple queues, so you are binding queue, you're checking this binding key with the queues, and which is exactly matching, you will send data to that. So this is called in direct. So topic is then fan out is, it is sending that message to everybody, all the queues. Okay, and then topic, so the third one is routing pattern, so star or hash based. Okay, so it will send data only who matches this pattern, wildcard pattern, and then consumer will read it. So this is the only difference in RabbitMQ and Kafka. Now Kafka versus RabbitMQ, let's talk about Apache Kafka deep explanation. Okay, so let's talk about Apache Kafka deep explanation. So what Kafka really is, it is not just MQ. So most people say Kafka is messaging queue. No, that is incomplete. Kafka is distributed event streaming platform that acts as a durable, scalable and commit log, because we store data there. What does that mean? Distributed. Okay, the first one is distributed, runs on multiple servers, clusters. So as I told you, like you will have a consumer, you will have a producer, you will have a consumer, and here you will have a, let's say, your messaging queue. But in that messaging queue you will have a broker, and in that broker you will have a topic, and in that topic you will have a partitions. Okay, and that partition is read by the consumer. But now you can have multiple brokers also. Okay, multiple brokers, so all those brokers will come into a cluster. Okay, cluster, and these cluster will manage by zookeeper. Okay, this is the theory about Kafka. So like this broker has to talk about this with this broker, and then they need to do communication, inter-process communication, and all those things will be handled by zookeeper. Okay, so it is distributed, runs on multiple servers or a cluster. Then event streaming, continue flow of events, not just messages. Commit log, data is appended only, never updated. Okay, Now traditional messaging, you send a message, once consumer receive it, after processing it often gone. Example, send mail, process order. So event streaming, Kafka style, you publish events continuously. Okay. Like Uber, cab. So in Uber, cab drivers are there and they send continuously their location to the server. So this kind of thing will store in a Kafka, right? Because it is a continuous events. Continuously. Event represent things that happen. Multiple consumers can read them. Okay. Event stay in Kafka for some time, replayable, and data is treated as a stream, not isolated messages. So now how Kafka works, so this one we have already seen it. Okay, you just go through this document and see. Now what are the core concepts? So core concept will be topic, partition, we have already read about it. Okay, and then this is offset. So let's say this is your partition and currently consumer A is here and consumer B is here. So we maintain this tracking using offset. Okay, so this one will come in offset management, and track consumption, enable replay, and then consumer control progress. Now consumer groups in Apache Kafka, this one also we have talked about. Okay, now why Kafka is so powerful? Because of high throughput. Okay, then normally random disk writes are slow. Kafka write data sequentially. It is not writing data here and there, but random disk will write data here, there, wherever it will get the place. So random write is jumping around disk, and sequential writing line by line. That's why it is faster. So and then sequentially as well. Then scalability, so you just add the partitions. Okay, so increase throughput. And durability, so data is stored on disk, and replication across brokers. Replay capability also there. Okay, so these are the for which Kafka is powerful. Now what are the weaknesses of Kafka? So complex setup, of course, broker, zookeeper, kraft, partition planning. These things you need to spend some time. And then not idle for simple task, low latency RPC remote procedure calls. Okay, and then better use you use for the low this simple task, you use RabbitMQ. So this is the diagram of Kafka. So you have multiple producers which is sending message on the topic, and inside topic you have multiple partitions. Okay, and then different consumers are reading those messages. So this is the architecture. And then important messaging patterns. Now you have a multiple messaging patterns, like first one is pub sub, then you have a work queue pattern, after that you have a delayed queue. Okay, and then retry mechanism, dead letter queue. So 5 messaging patterns are there. So now let's see what is publisher subscriber. I already explained. One message, multiple independent consumers. Okay, how it works: producer publish events, multiple consumers subscribe it, and each gets its own copy. In Apache Kafka, topic is equivalent to event stream. Okay, and each consumer group gets all messages. In RabbitMQ, this one will be done by fan out exchange. Okay, we talked about fan out. So when to use? So event driven system, when it is a event driven system. Okay, we are talking here about this publisher subscriber pattern. Notification, and so once one company will broadcast notification to all the clients, right? And then analytics pipeline as well. Now work queue pattern. Now what is work queue pattern? Only one consumer process one message, that is work queue. So just go through it. And then delayed queue, so scheduling processing. Okay, execute message after some time, so that is called delayed queue. Now the next one is retry mechanism. So retry mechanism will always be there. If processing fails, then try again. Okay, how many times? Let's say 3 times. So if you configure that number, and if it is still failing, then just put it into the dead letter queue, DL queue. So here this is the DL queue. Okay, so message that cannot be processed to go here. Okay, now what is the common problem with this messaging queue? So common problem is duplicate message. Okay, so why happen network retry or consumer crash after processing but before acknowledgement? So then again he will do the duplicate messaging. So what is the solution? Idempotency. So unique message ID, DB constraint, idempotent API. Okay, when you run it multiple times, the result will be same. So that is the solution. Consumer must be idempotent because MQ guarantees at least once delivery. Now what is at least once delivery? And at least once delivery is At least once delivery means a message will be delivered one or more time but never lost. Okay, so one and more time, if message is getting deleted, then it should be idempotent. Now, so the consumer may receive duplicate, but Kafka ensures you don't miss any messages. Message loss, so why happens, like if broker crash, okay, or consumer crash, or auto acknowledgement, what is the solution? Acknowledgement. Okay, you got the broker got the acknowledgement that okay, consumer read that message. Then persistent store message on a queue, so if it gets failed also, you get the negative acknowledgement from consumer, then you can again send. In RabbitMQ, durable queue we use for that, persistent messages we use. Okay, in Apache Kafka we use the replication. Ordering issue, so what is the ordering? Message processed out of order. In Apache Kafka, same key, same partition, so using this we achieve that. Okay, single consumer, and in RabbitMQ, single consumer and FIFO queue. That is how we maintain the order. So ordering is guaranteed only within partition in Kafka. And what is back pressure? So back pressure is producer sending faster, but consumer can process. So there is an imbalance. Producer is producing very fast and consumer is not consuming in that speed. So so what you can do, what will happen because of this? Queue size will increase. Okay, data will get stored piled up in a queue, so queue size will increase, and system slows down. Memory issue, what is the solution? Rate limiting. Just put a rate on producer speed. Okay, and then scaling consumers, so add more consumers, then they will work parallelly. And then queue buffering, so absorb traffic spikes. In RabbitMQ, we have a prefetch count. In Kafka, we have a consumer lake monitoring. So using that, like we know that prefetch count, this consumer can consume 5 messages at once. So we will add a rate limiter at producer side that just 5 messages at once you send, or something like that. So now let's talk about RabbitMQ deep concept. Okay, these all were the Kafka deep concept. Now this is the RabbitMQ deep concept. So in RabbitMQ, we see in exchange type. Okay, so exchange type, 4 types of exchange. Direct exchange, again I have written here in the detail, so just go through this. Okay, then you have a fan out exchange, we already talked about this. Topic exchange, and then the 4th one is header exchange, rarely used. Okay, then acknowledgement also we discussed. After that, prefetch count also we discussed. Okay, just I've given here in detail with some example. Now putting it all together, so producer send, order dot created, topic exchange routes messages, multiple queues receives it in RabbitMQ. Okay, then consumer process message, manual acknowledgement send, and prefetch count load. So insights, if you check the insights push model, now there are 2 things, pull model and push model. See, Kafka, let's say this is producer, and this is your broker, and this is your consumer. Okay, and you have different consumer, let's say. So here so Kafka is basically a pull based approach. Okay, and RabbitMQ is push based approach. So in Kafka, these consumer will pull data from broker. Okay, we need data, so they will pull automatically, means with themselves. So consumer will put effort here and pull data from broker, and in RabbitMQ, this broker will push data in to these consumers. Okay, so whoever consumer is ready, he will push data to those consumers. So that's why the concept of prefetch count is here for RabbitMQ consumers, because here Kafka broker is pushing data here, and he doesn't know that how much data this consumer can take. So he will check its prefetch counter, and then according to that push data to that. Okay, so push model, RabbitMQ pushes messages to consumer, unlike Kafka is pull. Okay, fair dispatch achieve using prefetch and acknowledgement. So at least once delivery achieved using manual acknowledgement. Routing power, exchange makes RabbitMQ very flexible than Kafka. If it is a simple one, then you just go with the RabbitMQ, because he has a routing power. You can route your messages on the basis of different exchange types. When to use what? So this one we already talked about, right? So if it is an event streaming, big data pipeline, high throughput, or replay needed, then use Kafka. Otherwise, if it is a task queue, simple architecture, complex routing, then go with RabbitMQ. Okay, Then there are few questions like how Kafka ensures ordering. So Kafka ensures ordering within partitions. Messages with the same key are sent to the same partition and preserving orders. This is we talked about like so they are independent to party. Like cross partition, it doesn't guarantee for the ordering, but yeah, within partition, yes. What is offset? So we check the offset, right? What is Kafka failure? How Kafka handle failures? So using replication, okay, it will create the copies of partition. Leader follower model, okay, so you will have a multiple, let's say multiple brokers in a Kafka cluster. So if one broker goes down, so other will elect as a leader, and that will work. Now if broker fails, another replica becomes leader. Okay, if consumer fails, it resumes from last commit offset. Now RabbitMQ, so what is exchange in RabbitMQ? Exchange is the routing component in RabbitMQ that receives messages from producer and route the messages to the queue based on the rules. Types of exchange we have already seen. What is routing key? We have already seen. What is acknowledgement? We have already seen. Sent by the consumer that he received the message. Now let's say someone will ask you to design a notification system using MQ. So how you will design it? Okay, this is the short concept actually. Right now here I will go in detail and will make another design video. When I will be making design videos like WhatsApp, YouTube, notification rate limiter, distributed cache, distributed logging system, that time I'll take this one. Okay, high level design questions. So now here if you see, I would design it using the pub/sub model. Okay, you can say that I will design it using the publisher subscriber model, and producer send event, message goes to topic or queue, multiple consumers like email service, SMS service, push notification service, that will be there. So what will be the key points here? Use Kafka for scalability or RabbitMQ for routing, retry mechanism for failure, DLQ for failed messages, and idempotent consumer. So whatever we have read, just use here. Okay, those things. How to handle duplicate message? So we have already seen that idempotent processing, unique message ID, store process ID in DB cache, or ignore duplicates. How to scale consumers? So Kafka, in Kafka, just increase the partition and add consumers. In RabbitMQ, add more consumers to the group. So use horizontal scaling, auto scaling in the cloud. Okay, create multiple brokers or that kind of thing. DLQ also we have seen. How will you design distributed event system? So distributed event system I will design using Apache. Kafka is the backbone. Okay, now here producer publish event, topic partition for scalability, consumer group for services. Okay, and schema registry. So in the schema registry, this is the central place to store message event structure. Okay, what will be the structure of the message or manage events? So retry plus DLQ and monitoring for the lag and failure. Okay, so what will be the key principle here? Loose coupling, event driven architecture, and idempotency. Now how to handle exactly once delivery, that is using the idempotent producer transaction and idempotent consumers, at least once plus. Okay, now Kafka versus DBQ. What is the difference between Kafka and DBQ? Okay, so DBQ is simple but not scalable. Locking is there, it is slow, it is not scalable. But Kafka is distributed high throughput and fault tolerant. Now handling back pressure. So back pressure is like consumer is slow and producer is fast. So we have also already seen that scale consumer. Okay, rate limit producer, use batching, monitor lag, and prefetch count. Push versus pull model we have already seen, and this is the simple analogy. Push is so what is the example of push? RabbitMQ. Okay, Netflix auto playing next episode. And what is the pull? So in Kafka you choose when to play the next episode. So this is the difference. So messaging queue are backbone of a scalable distributed system. Kafka is for high scale event streaming, while messaging queue is perfect for reliable task processing. So that was about the messaging queue. Thank you.